Hello everyone, welcome to course study on solid mechanics. In today's lecture, we are going to discuss the Rankine's formula. In the previous videos, we have discussed about the Euler's formula, and all of you know that Euler's formula is applicable to long column only and it is not applicable for the short column. So this particular disadvantage is overcome by the Rankine's formula. Okay, so Rankine formula is applicable to both long column as well as the short column. So that we are going to discuss in today's lecture. So Rankine formula, it is also known as empirical formula. Okay, so what does it mean? The Rankine formula is applicable to both short column as well as long column. It is assumed that the column or the strut it failed due to the both combined effect of crushing stress, which is also known as direct compressive stress, as well as the bending stress. Therefore the Rankine formula is given by 1 upon P, which is equal to 1 upon Pc plus 1 upon Pe. So as per this particular statement, Rankine formula is applicable to both the column, long column as well as the short column. Therefore, the failure of the column will take place due to the combined effect, that is crushing as well as the crippling or bending stress. And the Rankine formula can be given by mathematically, it can be given by 1 upon P, which is equal to 1 upon Pc plus 1 upon P. Okay, where P is nothing but it is the crippling load from the Rankine formula that we have to find out. Okay, after that Pc is nothing but it is the crushing load for the short column. Pc is nothing but it is the crushing load for the short column. Okay, and the value of Pc in terms of crushing stress can be given by Pc is equal to sigma c into A. The value of Pc in terms of crushing stress can be given by Pc is equal to sigma c into A. Okay, Pe is nothing but it is the crippling load which we have found out from the Euler's formula. Okay, and it can be given by pi square Ei upon L effective square. Okay, so sigma c is nothing but it is the value of ultimate crushing stress that we can use to find out the value of crushing load for the short column, and A is nothing but it is the area of cross section of given column. It may be a rectangular cross section, it may be a square cross section, or it may be a circular cross section. Okay, now as we know that Rankine formula is applicable to both short column as well as long column, so each column we are going to discuss in detail. Okay, so first of all we will discuss the Rankine formula for the short column. In case of short column, effective length of the column, that is LE, will be very small. Okay, therefore as L effective is small, then its square value will also be quite small. Okay, and hence the value of crippling load Pe from the Euler's formula will be very high. Therefore 1 upon P will be very small and hence it can be neglected with respect to the value of crushing load, that is 1 upon Pc. So what does it mean? For the short column, the effective length of the column is very small. Remember this one. Okay, as it is small, if we take the square of that effective length, then it again become quite small. Therefore as the value of denominator becomes small, okay, then the value of crippling load from the Euler's formula will be very high. Okay, therefore as the value of crippling load Pe is high, if we take the inverse of it, that is 1 upon P, then the value of P will become small. Okay, and hence as it becomes small, we can neglect it with respect to the value of crushing load. Therefore as per the empirical formula given by the Rankine, we have P is equal to Pc. We have P is equal to Pc. Okay, it shows that the crippling load from the Rankine formula will be equal to the crushing load Pc. P will be equal to Pc. This is for the short column only. Okay, now we will discuss it for the long column. In case of long column, the effective length of the column LE will be very large. Okay, as the L effective is large, if we take the square of it, it will be also quite large, and hence the value of crippling load PE from the Euler's from the Euler's formula will be small. Okay, as the denominator becomes larger, then the value of Pe from the Euler's formula will become very small. Okay, therefore the value of 1 upon P, now it is the inverse, it will become very high. Okay, and hence we can neglect the value of 1 upon Pc with respect to the value of crippling load, that is 1 upon P. Therefore, as per the empirical formula given by the Rankine, we have P is equal to Pe. It shows that the crippling load from the Rankine formula will be equal to the crippling load P, which is given by the Euler. That is for the long column. Okay, so in this way, the empirical formula or the Rankine formula is applicable to both short column as well as the long column. Okay, whereas Euler's formula is applicable to long column only. Now we will find out the mathematical formula based on the Rankine formula. Okay, so all of you know that we have the Rankine formula 1 upon P is equal to 1 upon Pc plus 1 upon P. Okay, therefore after solving this particular equation, we will get 1 upon P is equal to Pe plus Pc whole divided by Pe into Pc. Okay, so this is the value of 1 upon P. If we have to find out the value of P, then it will become P is equal to Pe into Pc divided by Pe plus Pc. So divide this particular numerator and denominator by P. We are going to divide this equation by P. Therefore, we will have the final equation P is equal to Pc upon 1 plus Pc upon P. Okay, this equation we have obtained after dividing Pe to this particular equation. Okay, so if you solve this particular equation, we will have this final answer. Pc will be, what is the value of Pc from the previous one? We have Pc is equal to sigma c into A. We have Pc is equal to sigma c into A. So you just put the value of Pc into this particular equation. We have sigma c into A whole divided by 1 plus sigma c into A divided by crippling load by the Euler's formula pi square Ei upon L effective square. Okay, so this equation we have from putting the value of Pc and by putting the value of P. Okay, therefore after solving this equation and after putting the value of I equal to A into K square, we are going to put the value of I is equal to A into K square, where A is nothing but it is the cross sectional area and K is nothing but it is the least radius of gyration. Okay, therefore on putting the value of I into this particular equation, we will get this equation. Okay, after making simplification, after making mathematical arrangement, we will have this final equation, and again after considering the value of Rankine constant, we will get final equation by the Rankine formula, and it is sigma c into area whole divided by 1 plus alpha into L effective upon K bracket square. Okay, where alpha is nothing but it is the value of Rankine constant, and it can be given by sigma c upon pi square A. Remember that alpha is nothing but it is the value of Rankine constant, and it can be given by sigma c upon pi square into E. Okay, and this value of alpha, it depends upon the type of the material. For different material we will get the different value of Rankine constant. Okay, so this particular table shows the Rankine constant for the various material. Okay, if we consider mild steel, for the mild steel we have the value of sigma c, that is crushing stress, it is nothing but 320, and the value of alpha will become 1 upon 7500. In the same way, we have the second material cast iron. For the cast iron we have the value of sigma c 550. After putting the value of sigma c into this particular equation, and after putting the value of E also, we will get the value of alpha 1 upon 1600. Okay, after that for the wrought iron we have the value of sigma c 250 and alpha 1 upon 9000. And the last one is timber. It is a value of sigma c 40, and the value of alpha will become 1 upon 750. Okay, so this is all about the Rankine's formula. Okay, and those are the values of alpha Rankine constant for the different material. Now we are going to solve the numerical based on the Rankine formula. Okay, so the numerical statement is as follow. Compare the crippling load given by the Euler's and Rankines for a circular column of 40 mm diameter and 2000 mm long. Take yield stress as 300 MPa and Rankine's constant as 1 upon 7500 and E is equal to 200 GPa. So as per the given statement, we have to compare the crippling load which is given by the Euler's formula and the crippling load given by the Rankine formula. Okay, and we have the circular column of 40 mm diameter and 2000 mm long. So the length is also given, diameter is also given. Take the yield stress value as a 300 MPa and the Rankine constant, that is alpha, equal to 1 upon 7500. Okay, and value of E is also given, 200 GPa. Okay, so we have to find out the value of PE and PR, that is crippling load given by the Euler's formula, crippling load given by the Rankine formula. Okay, therefore first of all we will find out the value of area. So area can be given by pi by 4 into d square. Okay, so on putting the value of diameter equal to 40, we will have the value of area 1256.64 mm square. 1256.64 mm square. Okay, in the same manner we are going to consider the value of moment of inertia, as it is a circular cross section, so Ixx and Iyy will be same. Okay, and it can be given by pi by 64 d raised to 4. Okay, therefore we will have the value of moment of inertia 125.66 into 10 raised to 3 mm raised to 4. Okay, once you know the value of I and area, moment of inertia and the area, we can easily find out the value of radius of gyration, that is k. K is equal to under root of I upon a. Okay, therefore which is equal to under root of, after putting the value of I and a, then we will have the value of k equal to 10 mm. We have the value of radius of gyration equal to 10 mm. Okay, therefore we will find out the value of crippling load. First of all we will find out the value of crippling load by Euler formula. After that we will find out the value of crippling load by the Rankine formula. Okay, so first of all Euler's formula we will consider. PE is equal to pi square EI upon L effective square. Okay, but the end condition is not mentioned in this particular numerical, so we will consider it as a hinge support. Both are hinge support. Okay, therefore pi square, just put the value of E, I and L effective square into this particular equation. We will have the final answer by the Euler's formula 62 into 10 raised to 3 Newton. So it will become 62 kilonewton. It will become 62 kilonewton. So the crippling load by the Euler's formula is given by 62 kilonewton. Okay, now we will find out the value of crippling load which is given by the Rankine formula, and the formula is PR is equal to sigma c into area whole divided by 1 plus alpha into L effective upon K bracket square. Okay, therefore we have the value of sigma which is already given in the numerical, that is the yield stress value, or we can see it as a crushing stress value also. Okay, and that value is 300. Area is 1256.64, that we have already find out. 1 plus the value of alpha, it is also given in the numerical, it is 1 upon 7500. Okay, so you just put that value into this equation, and the value of lambda, that is L upon K, will become 2000 upon 10 bracket square. Okay, so to find out the value of K, we have done this particular procedure under root of I upon A. Okay, so you solve this particular equation. After solving this equation, okay, we will get the value of crippling load given by the Rankine, and it is 59.525 into 10 raised to 3 Newton. 59.525 into 10 raised to 3 Newton. So in kilonewton it will become 59.525 kilonewton. So this is the difference between the crippling load given by Euler's formula, we have 62 kilonewton, and the crippling load given by the Rankine 59.525 kilonewton. Okay, and if we take the ratio of both the values, then we will have 1.042 as a ratio of these two equation. Okay, so the difference is nothing but this one. So this is all about the Rankine's formula and the numerical based on it. In the next lecture, we will discuss the concept of eccentrically loaded column. Okay, and in that we will consider the uniaxial condition of state. Okay, so we will stop here. Thank you.